everybody, welcome to the topic of rate of change. Today we're going to be doing small change. This is only a part of math syllabus. Okay, so what does this sign represent? This represents basically small change. So if I say this x, that means that there is small change in x. And how do we find that? That is that the final value minus the initial value will give you the change, the small change basically. Okay, and similarly we can do that for other variables. And a property is that the small change of y and upon the small change of x is approximately equal to dy upon dx. So we can use this to solve questions. Let's do a question of this to understand the concept better. Okay, so let's take a look at this question. So the two variables are v and r are related by this equation. So this equation is a must, because without that you won't be able to find the dv upon dr or whatever. So we've been given an equation and they've said that find the change in radius when the volume changes from 36 pi to 36.2 pi. So you see this is a very small change, 36.2 pi. So we can use a small change to find it. So we have change in volume, small change in volume, which is 0.2 pi, and we have to find the small change in the radius. Okay, so first of all we'll find that dv upon dr, so that will be equals to 4 pi r square. Okay, now we can equate this to the change in v upon small change in r, and because that was 4 pi r square and the change in volume was 0.2 pi, we get this equation. Now we can't solve this any further without putting the value of r, so we have to take out the value of r as well. So to take out the value of r, we have these two values given. We can put these in the equation, but both of them will give you different answers. So whenever you're doing small change, make this a rule that you take the first value, the original value. So you have to take the original value and either put this into the equation if it requires, or make this or find the other variable through this value. Okay, so we're gonna find r by this. So 36 pi is equals to 4 upon 3 pi r cube. Okay, so we can find r by this way. Pi gets cancelled and r comes as 3. So now we can solve this equation. So the change in r comes as 0.2 upon 4 into 3 square, and that makes the rate of change, the small change of r equals to 1 upon 180. So that is the small change of the radius. Now let's move forward to another concept of this. Okay, so to get the new value of an increasing variable, we have to add the small change to the original value of it, so we get the new value of it. Similarly, we do it for both x and y. Both of these should be related by an equation. So we can also take out a percentage change, which is the change upon the original value into 100. So this will give us the percentage change. Now let's do a question of this to understand this concept better. Okay, so in this question we've been given an equation relating the two variables. We've been asked to find the approximate percentage change in y, and we've been given that x changes from 4 by 2%, so it increases by 2%. So first of all, let's find the original value of x, which is 4. Now the increased value of x, which is 2% of x, so 2 upon 100 into 4. This is actually the small change of x, which will be 0.08. So the small change is 0.08. The small change of y we have to find. So we can take out the equation dy upon dx from this. So basically we have x to the power minus half. We will get minus half x to the power minus 3 upon 2, and this simplifies to minus 1 upon 2 and x cube in under root. Okay, Now we have dy upon dx. Now, as I told you, you have to always put the original value, not the changed value, the original value into the equation, and we can get the numerical value of dy upon dx. So minus 1 upon 2 into 4 cube is 64, and this will give you minus 1 upon 16. Okay, now that we have dy upon dx and we have change in x, we can find the change in y. So change in y upon change in x is equals to dy upon dx. The change in x was 0.08, so 0.08 upon minus 16, so the change in y is equals to minus 1 upon 200. Okay, so this is the changed value of y. So to find out the percentage change, we'll put it into the equation that change in y upon the original value of y into 100 is equals to the percentage change. Okay, so the change is minus 1 upon 200. Now it is being divided by the original value of y, which we again have to find now. So there's a bit lack of space here. We'll do it over here. Y is equals to 1 upon under root x. Now again we have to use the original value of x, not the changed one. So under root 4, so we'll get y is 1 upon 2. So again y 1 upon 2 into 100, and this will give us minus 1. So minus 1 percentage is the answer of this question. That means that the y value is decreasing 1% from its original value. Okay, so that was all from a small change from the topic rate of change. Thank you for watching. Goodbye.